right, let's go. All right, so I got an email from the creator of the Go programming language because, hold on. Let's go to my pictures, go to my screenshots. I think it's this one. You are crawling too fast. Come back in a few minutes. Mail questions to NJA Sloan. It's just his email. And then this guy. And if you look up this guy, he made the Go programming language. Anyways, so I sent him an email and he emailed me. 38K followers. Anyways, he's in Cambridge. But anyways, he pointed me to this. Oh yeah, and for reference, what we're doing. Oh shit! Wait, do I need that? No, I need the internal file format. Oh yeah, we need this. Yes, eyes help. All right, so basically we're gonna take this and make a parser or something. So there's two ways that we can do this. Let's open up. So this code is all based on JSON that I wrote last night. Dude, why is it that literally every time you use this thing, Rust Analyzer's like, guys, restart it? Why is that? Someone tell me. Okay, anyways, so I cloned this repo already because it took forever. I mean, it's like 400, it's like millions of files. So I didn't want to just have you guys sit through that. Make sure you shallow clone if you're going to clone it. But so, yes, we have all these files that are like in this format. And then there's two ways that we can probably build the graph. The first way is to just use a regex and find every single A code. What happens when we get to 1 million? And then we just create an edge from the beginning of the sequence to everything else. The other way to do it is that we only look at these %y codes. The annoying thing though is that let's see if this one has it. Sequencing context. Kolakowski sequence. All right, let's go further down because some of them have them and some of them don't. So let me just see. What is it called? Is it called sequencing context? Yeah. Okay, so some of these have this thing where the references has this sequence and context, which doesn't even make sense to me. And then also this. And I feel like we probably don't want these in the graph because they're not mathematically relevant. So if we're trying to find like links between mathematics, we're not going to find it with those edges. So we probably want to get rid of those edges or just not add them in the first place. I'm going to go take a shit. What is this? Decimal What is so fundamental about the golden ratio? It's an irrational number, right? Whoa, what? The golden ratio of phi is the most irrational among irrational numbers? What does that even mean, dude? Is successive continued fraction convergence? Oh, that is a real word. Are the slowest to approximate its actual value. How do you prove that? That's one of the craziest things I've actually ever seen, dude. Wow. That's super fucking cool. All right, so I think um how do we want to do this? All right, let's just start with the first 1,000. We'll start with A000. How many are there in here? 100 or 1,000? There's 1,000. Okay, so we'll start with the first 1,000. I'm gonna turn this on. Okay, so all right, I'm just gonna try this. Hold on. I have a bunch of files like the above. Let's go do this. I want to write a Rust script that is there a compact? I mean, you could just write it into GraphViz, but the first grabs. Holy fuck. It's 6, right? Alright, let's see if that's too long. Interesting and practical. Wow. I've never felt so special. Just write the fucking code, bro. Should we start this over? Should I delete all this code? We don't need DLM. Okay, this is what I'm gonna do. Okay, we're just gonna start a new one because I don't want to give a fuck. We're gonna actually put this up here because this is the main one. Okay, cool. Okay, so yeah, let's just try it. Okay, so let's just do this. copy path. Yeah, read to string. Then you get this. But does this? I don't know how to parse this. Because I want the actual. What's wrong here? Oi, oi, oi. Dude, that is one of the most annoying things. Can I just do this? What is it called? Like that? Something like that, right? This is a raw string with. Do they have a doc on raw strings? I think that should be fine. All right, so we can close this other one. What? Thank you for not prompting me at all. Oh, there we go. Yeah, it's because my computer crawls to. What happened? Let me try to do this. See, if I do this, does my CPU usage go lower? We'll see. I should just turn off some of these things. Maybe these things are doing some bullshit. Disable. 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 Yeah. What other nonsense is in here? Alright, I don't know. Main ID. I think all we have to do is this. Okay. And it's a hash set. Perfect. Okay, so that's all we have to do. Okay, let's look at the Rust graph library. Graph Rust. I think it's called Pet Graph. Pet Graph is pretty under. Like, it's not that good. It's got like some stuff, but I don't think it's that good. Okay, so we want a directed graph. Okay. Nice. Okay, cool. I'm just trying to figure out like, okay, so what we want to do now is copy Beth. Um, we want to add a step where we filter out any of the A codes from the second regex that don't occur in the folder/file set. All right, it'll probably figure that out. Just write the code. Why does it have to like explain to me like I'm a total idiot? Dude, okay. Someone, how could it possibly get this wrong? Does anyone understand that? That is super bizarre to me. How could it get that wrong? That's really weird. Available A code. Right, okay, that's fine. All right, I'm okay with this. Except for this super fucking bizarre... Oh, wait. Can you just do this? I thought you had to do like a... I guess not. Oh my fucking god. I don't give a fuck. But I actually don't really get this. File name dropped. I don't really get that. I thought you could just throw around clones. Oh, wait. Can I do this? It doesn't do anything. We don't need to add anything yet. All right, let's just run it. What the fuck? Hold on. What is it doing? It's saying okay, so all right. Now make it good. Dude, coding is so much easier when you don't really have to like think about nonsense. Yeah, this is not too bad. We'll have to change that later, but that's fine. Okay, then here, what do we get? Instead of extract main ID, I don't know if we need to do all that, but all right, let's see if that works. Cool. That's pretty good. So for the first one, you get the main. Wait, what? Oh yeah, wait, hold on. I want it to be a vec actually. Uh, what happened? Oh, probably because some weird caller. Oh yeah, okay. Fuck you. Um, I guess that's. Oh jeez, what happened? Oh my god. Um, find iter map Esther to string the filter that collect and collect because this we actually want it to be. We actually want it to be a set there. So I guess collect does the deduplication. Right? And a little thing for Rust Playground to see if collect to hash set. It must. I don't even know why I'm asking. Okay. Is that how many there are? Okay, cool. So this is kind of a weird thing. Yeah, it's kind of weird, but whatever. Okay, so what we can do is we can pet graph. I get a digraph. Okay. I just say use pet graph. I don't know. Yo, I hate docs like this. Like, show me how to do what I want. You know what I mean? Okay, graph from edges. It's not really how I usually do this, but what if I just did this? Let mute g equal to pet graph die graph new. Can I do that? Yeah, of course not. Wait, what happens if I do that? Oh wait, no. Fuck, that's not what I wanted at all. I wanted... Could not find... I don't know why that's not in the suggestions. Can I do this? I think I have. I think it's because it's a flag. So I think it's a flag. Let me read this. Yeah, one would think that, right? Oh wait, did I just... Hold on. Hold on. Actually, I'm an idiot, I think. Let's see here. Stir. We want... What are the two parameters for that? I don't even think this works. Let me just copy this and see if this does anything. Okay, let's just see. How far does it get? All right, I guess that's right. What are the... Oh, this is the vertex weight and this is the edge weight. Okay, so we can just make them unit. All right, so that's fine. We'll make them unit. Fuck. This and this. Because we don't need any edge weight. We just want the graph. Okay. Makes sense. Wait, what's wrong? What happened to my fucking... What happened? What the hell? I think Rust Analyzer crashed. Okay, so now what we want to do is, let's see, what kind of things do we have here? Hello? Hello? There we go. Okay, it's not bad. So let v equal, okay. Oh. Right. But it should be in order. It should be in order, so we don't really care. Oh, yeah. Okay. Then process file. What does this do? Okay, so we don't want to print anything. We just want to return the... it just runs the regex, and then this does the filter. Okay, so we can just do this. And it returns this. We'll call this out neighbors. Okay, then, yeah, cool. That sounds good. Oh, and it's a string, so we need a, okay. That's silly. What? How did it do it? Dude, this is not a good, this is, it's all right. I don't want to hate. I won't be a hater. Add an edge from A to B with its weight. Return the index of the new edge. Panics if the node doesn't exist. Panic if the graph is at the max number of edges for its index type. Interesting. Okay. Can I just do this? Oh, great. Maybe I should just compute the tuples. I guess what I could do is I can just, yeah, make the tuples first, but that's stupid. I should be able to just do this. Node index? I remember I had to do this. Why? I don't get this. This is written so confusing to me. All right, but I guess this is what we're going to do. Is that a thing? How do I... Where does that come from? I don't know. Let's just see if it figures it out. So we want to do... I don't know why... Matrix graph. Dude, I hate this fucking graph library. What? Bro, I swear. Wait, this returns a... Okay, fine. Let's see. Can I get this to work? Stable graph. I don't know which one of these to use. I think it's this one. No. I have no idea. Let's see. Where does this come from? Is it stable graph? I have no idea. Who the fuck wrote this library? Can we hate for a little bit? Who wrote this horrible, horrible library? It's just not maintained. It's crazy that nobody does graph stuff with Rust. That's so weird. This library is dead. It was made 10 years ago. And where is this guy now? Wow, dude. Oh, great. Another fucking master derp. Okay, cool. Minimum spanning tree. That's pretty cool. Let me read these comments. Create an undirected graph with I32 nodes. But see, that's what's so weird. Oh, I guess. Yeah, I guess. Okay. That's just right, because really what happened was some guy just needed to do something with a graph, and then he wrote this simple library, and then everyone just started using it. But it's like not. Okay, I think we're ready. Oh, right. Let's do this. Can we just do this? This should return a U size, right? Are these the same type? What does this do? Yeah. Okay, cool. Oh, fuck. That's super annoying, but that's okay. I'm a dummy. Huh? Uh, that is so insane that it really thinks it needs to. Whatever. I don't give a fuck. I don't give a fuck. Don't give a fuck. Dude, programmers are like brain dead that they think that, oh, I need to know that I need to import this stupid bullshit. This is probably too big. Is No, but is there a dot parser? That's what I'm trying to. Oh, okay, cool. But what does it load into? Let's try this. Okay, so J. Let's see what's. Did it switch? Because it's probably still using freaking. Okay, I guess not. No, but see, it doesn't actually. Okay, wait, hold on. Let's see if this is reading and writing graphs. Dot. Oh, I hate that sound. Oh, wait. Nice. Doesn't have writing. Okay, so wait. So we want to actually rm graph viz. Let's see. Yamedale. Okay, cool. So now how do you load it? Oh, great. They've got a whole bunch of extension things. That's fantastic. I don't like those. I guess it makes sense. All right. So usage. For example, an edge list file. Okay, so dot. Hold on, I probably have to do this first. Oh, yeah. Why am I so dumb? I should have known that inevitably I was going to use Julia. Enable. Okay. And wait for oh, God. I knew it. It's just a broken ass language. How do software people even live with themselves? I don't know. All right. Wait, hold on. You need to activate this environment. Hello. Thank you for not responding to me at all. I mean, what are you doing? Oh, wait, did I? Why doesn't it work? What is going on here? This was just working. I honestly. Okay. Oh, there we go. Oh, great. Y'all are so fucking annoying. Didn't report that I needed to restart. Dude, it wasn't until I did a. Oh, great. No, it actually doesn't work. Why doesn't it work? Someone tell me. Total fucking nonsense. Oh my god. Okay, wait. Is it because of this? If I just disable this, let me see if I can get it working. This, obviously, we can just disable all of this horrible shit. Okay, let's see if I disable Rust Analyzer and I restart. Can I get the basic thing to work? Why is the extension broken? Dude, I just had this working. I'm so confused. We can disable this too. I was so confused because Why does that work? Come on, bro. Is it because I'm in a workspace that things just don't work? Let's try that. Honestly, wouldn't put it past me. This thing fucking sucks. Never mind. It just doesn't like this thing for some reason. But I don't know why. Oh, there we go. It just took forever. Is it working here? That is so random, dude. That is so random. Just doesn't work if it's in a workspace or something. Whatever. At some point, you just have to do something. Okay. Load graph. Graph dot dot. What is that? Graph key? I don't know what that means. Dude, the Julia language server is broken. Hello? Can I have anything? Y'all thinking about trying or no? Because I don't know. Stupid as fuck. Of course it just links to the... How are you supposed to do anything in this life? Ext O dot, probably O dot, oh, IO dot, okay. That's what it is. What was it called? Dot format. Oh, dude, that's cool, man. Fourier analyst. I like that. Yeah, so okay, here I'm just getting frustrated by having to write shit code all the time by things that don't work. But yeah, we're looking at the online encyclopedia of integer sequences. I found this repository that has every sequence file. So I cloned it. How long ago was this? Are you still? Okay, cool. It was recent. And so then I wrote this Rust. Oh, this is the old one. We can close this. Do you work in differential geometry and PDEs? That's cool. Okay. So we wrote this code that looks at one of those, that looks at a folder in the sequences. Let's see. Let me show the actual thing. So in here, you go to sequences, and then you have 1,000 sequences. So this one is the number of centered hydrocarbons with N atoms. Dude, that's fucking rad. Isn't that so sick? So anyways, then you go down here, and you look at, there are these percent Ys. Well, actually, right now, I'm looking for basically a specific regex, A with 6 numbers after it. And we're just creating a graph where the edges are the hyperlinks. So, and then so I already have a graph in GraphViz format, but the problem is, I think maybe, I mean, this is already pretty big, you know, a few thousand edges. And, okay, yeah, of course, dot format not defined, great. Anyways, I tried to use an online viewer. Okay, if I do this, let's see if this works. I'm so sick of this. Okay, there we go. I think that's cannot parse. What if I just use GraphViz itself? Why am I even trying to use... Let's see, let's go get GraphViz. Ay, ay, ay. This is why I hate computers, man. It's like, can I do anything? Windows exe installer, that looks good. Okay, fine. Wait, I want it to add to my path. Do not add. Add path, yes. Okay, cool. That looks like it's... Right, okay, so... It's kind of like the worst, but I cannot be bothered to deal with Julia's brokenness. Okay. Now I have a dot file. How do I visualize it? I think there's a way to get it to export to SVG. SVG is great because then I can... I mean, I wish it was interactive so I could pull it apart, but... Why is it going so slowly? Alright, that looks good. I'm just going to change that to PNG. You know what? I probably could... Fuck. Dude, Mathematica is so good. I just wish it was not so expensive. Wait. Oh, no, mind. Yeah, that's fine. But we shouldn't have any loops. I just want to make sure that there's no loops. But there is a loop. There's a loop. How did that happen? That's not right. I was supposed to remove that. All right, let's look at something else. 981 to 981. Why are the loops here? Bruh. We need to rewrite this, so... That seems good. I'm going to try to... That should maybe reduce the size of this graph. Okay, yeah, that's a lot better. But still... All right, let's try PNG. Maybe PNG is faster. I mean, it's just still a pretty big graph. And it's giving me nothing. I just want to look at the pretty pictures. I just want to look at the pretty pictures. Let's look at the first 100. To the first 100. So oh yeah. Okay. All right, here we go. The edges. Okay, all right. So this is never gonna finish. Okay. Well, if that's the case, let's try to do the first 100. Available A codes. It gives me a directory. Okay. What I'm curious about is actually if I do this, because this could be totally wrong. All right, so what we're gonna do here is okay. Then all I want to do is reader. What is this? This returns like a type called reader, like option reader. Oh great! And now is the Rust analyzer disabled? It's literally like I have brain damage. Yeah, it returns a freaking result. That's annoying. But okay, fine. I don't really care. I just want to make sure that the sequence files are in the right order. And unwrap.collect. How do you do this? It's like it's like that. Right. Okay, wait. Dude, it is actually like I have brain damage. Wow, programming sucks. I would not want to be a programmer. Yeah, yeah, great completion, idiot. All right. Okay, cool. So, all right. That's nice. Should we try it? I mean, it's just such a big ass. Your graph is data is private. Yeah, except it's not. Lel. Come on. Come on, bro. What are we talking about? All right, so. Uh, so instead of this. Um. Instead of this. So what is this? This is all of the codes. So all this should do now is just call map. It calls map and it. Okay, yeah. So. Um. Wait, actually, I probably can just say file name to a code. Okay, cool. That is useful. So now, right? So this entry is a dir entry. Yeah. Okay. Into string unwrap. It returns an OS string. Neat. Okay. So now. Um. I think all we have to do is available A codes equals. Oh wait. Um. Why doesn't this work here? Uh. To unwrap. Wait, can I do like a? It's like a filter? Isn't it? Oh, is the map okay or something? I forget what it is. Or vex string or whatever it is. I don't really give a fuck. It's like coding is so stupid. My mind is going so much faster than this stupid fucking type system. Right, so you read this directory, you unwrap it. So this can return a result. And then when you unwrap it, this part gives you, this is a vec, okay, so whatever. Okay, fns.map, .iter.map x to x.unwrap collect. It's just so dumb. Oh wait, can I just do dot first? No, dot okay, cool. So now we have a vec of dir entry. Wait. What do I want actually? Available A codes. What was that before? No, I shouldn't have gotten rid of it. Available. It should be just a vec of string. Yeah, this is kind of silly, but whatever. All right, cool. So this is fine. Wait, so we could actually just do this A code to use. Oh wait. File name to A code. Right, so this won't work because this is a dir entry. So what you need to do is some bullshit like dot file name dot into string dot unwrap. Isn't that so fun? Just like a whole bunch of random things that they're like, yeah, do this, do that. What does this function take? A string. Oh my god. There we go. Okay. So this is a vec of string. So we're just going to do this. Fuck. I hate this. Okay, we have this directory. All right, I'm just gonna ask GPT because it's really not worth my time. All right, let's see if this works. Yeah, Rust is for idiots. I stand by that. Rust is for idiots. All right, so what we want to do now is for idiots that want to just not do anything with their life. Okay, make graph. It's not gonna work. Oh yeah, well. Oh my fucking god. I am so pissed off with everything. Oh my god, did it really do that? I couldn't remember. Whatever. I don't give a fuck. I am not. I'm not gonna let this bring me down. Oh, cool. She was right here. Actually, we don't need that. Okay. All right, we're ready. Now we can get a small one that we can just look at. Nope. What? Oh my god, I'm so fucking mad. So where's the backtrace? Can we do this? Will this work on Windows? I feel like Rust backtraces suck. Like, doesn't help me at all. All right, whatever. We can just do this. Where is this getting used? Oh wait, okay, yeah. Iter.map. God, this is so. There we go. Oh right, yeah, that doesn't. Okay. So now, wait, why is this so big? Oh yeah, because we didn't actually. Of course not. Of course not. Yeah, no. Why would you want to be able to easily do anything? Why would you want to be able to easily do anything? I want to make everything as hard as possible for myself. Okay, cool. I just want to see what it looks like, dude. It's so ridiculous. Online graph files. Come on, can we get this going? Interesting. Nice. Okay, so we need to get these. Oh, that's a stupid ass. Okay, so we'll add a usize node label. I mean, it's actually dumb because the. Wait, no, wait. I think I can do this. I think it'll default to the thing. It should. Can we need to get rid of this. Right. Yeah, see, that's at least better. And these are all shifted by 1. Everything goes to 40. 40 and 78 have really high in degree. All right, so let's go to, so this is actually 41, so A00041. The number of partitions of n, the partition numbers. Yeah, that's pretty, I don't actually understand what that is, so I'll have to look at that. Oh boy. I'm really curious how big the All right, I really want to just build the whole graph.
Okay, welcome everyone to my continuation of what are my favorite theorems. My very biased collection as usual. Today I would like to talk about one of my favorite combinatorial objects, and I was just thinking whether actually the topic is really also something I like. So I really like partitions.
He's known as one of the mathematicians with perhaps the most natural talent for maths, and it's a man called Ramanujan. He was an Indian mathematician. He started with no formal training in mathematics, but just by working alone, isolated, he was able to come up with all these mathematical facts, these theorems, all by himself. Some were rediscoveries of things that were already
I have it muted?
some new. And he sent these to Cambridge mathematicians, and they recognised his talent. And he was invited to come to Cambridge and show off what he could do. When we're filming this, a film has just come out all about Ramanujan. This film just concentrated on one achievement. It was something to do with partitions. So partitions is about the number of ways we can break down a number. And we take a number, an integer, and how many ways can we break it down into positive parts? And to prove that I'm a serious mathematician, I'm going to illustrate this by using Duplo here. Let's say we take the number 4, and I've got 4 units of Duplo there. How many ways can I break this down into positive parts? So I can start with this. It's a tower of 4, or I could break it down, right? I could have a 3 and a 1, right? Or I could have a 2, a 1, and a 1. Or I could break it down again. I could have 1, 1, 1, 1, and there is one I've missed there, if you notice. I have missed out breaking it down into 2 and 2. So then there are 5 ways to break this down. So if we draw this out, we can either draw it like this, 1, 2, 3, 4. We can do a 3 and a 1, like that, 2, 2. We can have 2, 1, 1, 1, 1, 1, 1, like that. So this is what mathematicians actually do. They do it this way because by seeing it as a picture, you can actually make conclusions about partitions which are easier to see. The French do this slightly differently. The French draw them like this. You can have a row 4 like that, and you can have a row 3 with a row 1 like that. So slightly the other way around, or you can do it like this. Bum, and then the last one here, 1, 1, 1. So it's a slightly different way of doing it. So my favourite footnote from a textbook. Do you have a favourite footnote from a textbook?
Okay, integer partitions, very interesting. Okay, so now I really want this graph. I expect it to be huge, but I really want this graph. So now, let's see. We want to do a traversal of. Okay, so I'm gonna close this. All right. Okay. So let me get rid of this. Okay. Filter map, filter map, filter map. It's made by idiots. Okay, just do it. Just do it. Okay, that's pretty good. And then make graph fn's use reader directory path. No, you are dumb as brains. I don't know what that means, but this guy's dumb. I don't care. We don't give a fuck. We don't give a fuck. It's just called Seek? Oh, it's just called Seek. Okay, that's fine. Nice. Okay, cool. So then all we want to do is okay, so the first step, you get all the subdirectories, then you map get seeks. Okay, fine. So get one. Okay. Well, we could just write a for loop. Okay, so okay. Okay, all right. So what are we doing here? Gets all the file names and makes a single massive vec. Okay. This is just so painful, bruh. So what do we need to refactor though? We actually do need to change something because here we do this, but this is not going to work. We want all the file names And we want to iterate the file names. Bro, okay. Println. Oh, let's go. That seems about right. Seems a little low. Okay. So what's happening now? We have all the file names. So now we just need to change. Let me move this helper function up here. Okay. So now we just give it a set of file names. So this is just going to be okay, so we can do this. We can do this. Now, for we have a file name to A code thing, right? Wait, God, coding is so stupid. Ugh, no, I don't want Julia. Why does it keep thinking that I want that? What happened? Okay, whatever. It stripped it. Why did it strip it? Why did it think that that would be cool? So much of this is just dealing with file paths. I think hundreds of thousands of lifetimes have been just dealing with this nonsense. Okay. Real trap shit. Okay, let's try it again. Boom. Okay, cool. So that is exactly right. So now what we want to do is file name to A code fn's 0. It's probably going to give me some stupid error. Oh, it moved. It moved. Okay. Okay, we're almost there. And then what? See, the problem is we're going to have to fix so much stuff. I just want the graph. Why do I have to do any real work? Why do I have to do any real work to get what I want? Okay. Yeah, that's nice. So maybe we should make the A code the, but it's just gonna make it so fucking messy, dude. Okay, well, so now we have three six nine five five nine. There's I don't know what happened to the missing ones. Maybe at the time I cloned it. I don't know. We can actually see. I mean, it's from like hours ago. I don't know. So that means that we probably... Okay, so let's uncomment this thing and start to make this work. We can delete this. So it takes a... Yeah. Where are the pet graph docs? Okay, I see. Okay, so we could just make it U size. The weight is V. Okay, so then FNs for profounding that okay. Okay, so first we do this O of N pass, which is fine. For file name in this, we probably want to do this. Process file. And then available codes. Okay, we can do that. The filtering process. Borrow. Expected path. Okay, wait. Will that work? Where are all of these weird yellow things coming from? They're bothering me. Okay, cool. So I think that should do it. Now, I'm very curious. Okay, so we want to just do if I mod 1,000 process die files. Okay, cool. Shit. All right, let's see what happens. Oh, oops. I'm a silly goose. I'm a silly goose. Oh, wait, hold on. Let's do this. Big. I don't even know. See, that's weird, right? So this should be 1, and this should be 0. Yeah, so the problem is we want to do everything just with A codes. We want to do everything with A codes, so that means that when we add an edge, we need to find the index. So we wait, A code to U size? No, that's right. That's fine. The problem is that when we do add edge, we actually want to add an edge between node labels, which I wonder if you can just do that. Maybe we'll build up a hash map, and I'll just look at it. Perfect, knows what I want. A code to index. This is not, wait, we don't, do we want the A code or do we want the U size? We'll use the U size. So then we want to, now we want to, I think it should all be consistent now, right? Oh, that's useful. Cool. I feel like that should be fine. Let's see what happens. Jesus. Okay, so this is not gonna work. Wait, but I wanna. Wait, does this overwrite or is this gonna duplicate? Yeah, see, that's not gonna work. So we're just gonna do this. This is ridiculous. Holy fuck. Okay, well that makes sense. Right, it doesn't even have the edges. Writing just the file. Oh, but it has to do the rewriting every time. Yeah, no, so oh, gosh, this is a total mess. All right, so what if we did this? What if we did this? We give it um all right, we're gonna do 5,000 and then we're just going to panic. No, but it'll panic immediately. If I mod 5,000, we're just gonna do this. If I equals 5,000. I just want to see how big it will be. It's probably gonna be massive. There's 350,000 nodes. What am I getting myself into, bruh? See, this is all just writing. I think I/O on Windows is slow, though. But I'm not sure about that. But I've heard stuff about that. Perfect. But I like the Julia Graphs library, so... Wow, there aren't as many edges as I would think. Let's see. I mean, there's a lot of edges. Oh, wait. Run it again. I think this is default. Yeah, okay, so there's off by 1 up until I think like 350,000 for some reason. Not sure what happens there. All right, so let's see here. Okay. $369 to 407. Okay, so yeah, I mean that's a lot of edges. That's not a ton of edges though. Graph ML. Maybe we'll try to use Network X. Wait, hold on. We need to do some. Bro. We need to do some checking. It's all Python. Is it slow? It's written in Python. There's no way it can be fast. I bet it's just like untenably slow. Okay, then I guess we have to fucking use maybe we have to do this. But pet graph might not have a way to export. Oh, fuck. All right, wait, hold on. Dude, there's no way that this is not huge. You know what? I know I deleted it, but I'm going to try to make it work again. We should just look at the tests. Dot tests. What is this? Has isomorph. Is there test files? Where is the test files? Two graphs dot 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 dot. All right, we need to close all this crap. You know what? I didn't actually. Yeah, I forgot, because what we could do is we could start to prune. The thing is, I'm not even far enough along for the edge count to be the limiting factor. It's literally just that there's so many nodes and that the code is slow. Okay, well, oh wait, but what if there's no name? All right, well, I don't care. Okay. Graphs, graph IO, parser combinator. Okay. I mean, I could literally just write my own parser. It's not even that freaking hard, bro. Okay, good. Oh, whoa. Oh, yeah, no, this is Julia stuff. Yeah, that makes sense. Okay. Read test. I don't know what that is, but write test. I don't know what that is. Load graph. Wait, how do you make it a raw string? How do you do it? Still. Oh wait, is it? Oh yeah, right. There's just the highlighting is not. Okay, cool. Oh wait. Dude, this is so annoying. Saved 3 graphs. Save. What? This doesn't even exist. When was the last time this shit got run? I doubt that these tests run. Oh, you know what? It's probably because the label. It probably doesn't support. God damn. Okay, wait. So let me just try to do this. Or wait, actually, I'll just. Oh, there's 2 in here? That's weird. Isn't that great? What a good error message. Cannot parse. It's so useful. It's seriously so useful. Okay, wait, what about this? If I just did this. Oh my god, it just doesn't work. Python's too slow, I know it. Okay, I think I might take another approach. And instead of even doing anything with pet graphs, I am going to do something better. Because I have ambiguity about whether or not this is correct because of this node index thing. So what I'm going to do is copy all this, say, I want to rewrite this to not build a graph, but just incrementally write rows to a CSV where the first column is the source vertex A code, and the second column is the dest A code. Honestly, I feel like this should be super easy. Because then I can just use csv.jl, and I could just say the unique vertices that were found are the graph. Yeah, this is a better approach. Okay, so cadd csv, cadd serde-f derive. Okay, cool. That seems a little retarded, but whatever. Because now it's just A code to A code, and I can verify that it's right pretty easily. Nice. And plus, now we just know the... This is great. This is way easier. I don't know why I was trying to use this terrible library. Don't use libraries. Don't be a chump. Don't be a chump, bro. Do I look like a chump? All right. Calm down. I mean, we're already at 10,000. Should I just wait for this? I'm going to take a 5-minute break. Honestly, I was expecting the number of edges to grow way, way faster. I was expecting it to be like in the millions. So this is an average of like 5 edges per node. Wait, why do we have, dude? Oh, fuck. Okay, I'll just have to filter those out. But we need to say, if, damn, I'm a dumbass. We're gonna also do, okay, so now we can just do this. So I want to try this. So now we can do, because Graph.io is just a broken, I mean, I guarantee this thing has like 1 user, maybe 2, but it's just like total garbage. Parser, add CSV data frames. Okay, df is equal to csv.read, g.csv data frame. Oh wait, we probably have to do this, then this. I'm so much happier with this approach, not using petgraph. Hopefully it'll just give me an unbroken, yeah, you know, it's not a big deal. Oh, sick. Yeah, okay, so df is equal to, oh, perfect, they can use string 7. That's actually super hype, because it'll be compact. That's really cool. Okay, so I'll just chop off the last one just because. So now what we want to do, we'll call it vids. Vids. Yeah, perfect. Okay, so we're actually like, I should just leave this running because we will get it all done. And my expectation is that the number of edges per vertex as we go through this is going to drop. I don't really know how to verify that, but it probably will. Okay, cool. So now G is equal to all right, now I can just use graphs.jl, which is actually a good library. Like graphs.jl is actually good. Construction. The problem is we need. All right, let's just do this. Digraph. Add vertex. Wait. No, that's not what I want. Oh, really? What? We need this? Probably way slower, dude. Oh, wait. No matter. I like that. Okay. Easy. Okay, wait. So if I do v is equal to add vertex g. Okay, cool. So that's actually perfect because it's one indexed. That's exactly what we want. So that means that we don't have to shift it by 1. But there are holes. So we can't just... See how far are we into this? This code is really slow. We're 1/6 of the way done. Okay. Damn, that's kind of annoying because we do want should I go to CatLab? Dude, CatLab has such good graph interface. I love CatLab. Documentation makes absolutely no sense, but this is pretty good. I don't remember how to do it though. How do I build the... Ooh, see, that's what I want. Do I even need that? All right, we're gonna be cringe lords, and we're gonna do... The thing is, CatLab actually rules. So I don't know if I should feel like a freak or a baller. Yeah, add vertices G, label equals, okay, cool. So, okay. The fuck is bijection? Indexed labeled graph. What does that mean? What does that mean? What does that mean? I wonder if this code still works. Labeled graph. Labeled graph. 300,000. So we've. Oh no, we crossed it a long time ago. Wait. No, what was I? I don't know. Okay. Okay, cool. So dude, where is it still getting that from? It was deleted so long ago. So we need to move this down. And then the children thing doesn't work. So we'll have to... We're not going to use this. And the reason for that is that if I'm going to use labels, then I might as well just use CatLab. Okay, so NV equals length vids. Cool. So we had 60,000. You can just delete this. Okay, we have a... Hope that works. Cool. Label equals vid. Wait, vids has missing in it? Okay, cool. So there was no... Okay. Oh. Let's go, bruh. Let's go, bruh. I always forget this indexing thing. It's so complicated to like. I mean, it's mainly just because I'm stupid, but I always. It's like, okay, I want to find the. Yeah, it's like this thing. That should be fine. We'll just do that. Vids. Wow. That was fast. That was really fast. That was cool. Very, very neat. What time is it? It's probably like noon. Yeah, it's like noon. It's ridiculous. Oh my god. Okay, so that was really easy. So now how do I convert this to a graph? So now how do I convert this to a graph? Let me read my other code. How do they get the draw? I want to draw. There's no way. It's just too big. I really wish I understood this better. Well, they've added more to this, I think. What about if we do graphs.graph of G? Bro, that was too easy. Okay, so wait, so we want to do connected components. I hate this error. What? Wow. Oh, wait. Interesting. I wonder what this is. That's neat. There's a connected component with 96 things in it. It's all alone. So wait, can we get the vertices of that connected component? Yeah, we can, right? Okay, so sort CCs by equals length. Then we would take end minus 2. Then we want to take SDG of this, and that gives me the induced subgraph. And now this, I wonder if I can convert it back to a CATLAB graph. Well, actually, no, we don't even need to do that. We have the vertices. So then all we need to do is catlab.graphs.induced subgraph of G. How does this work? Can we get this guy? Can we get a motherfucking dog string up in this bitch? Can we get a motherfucking dog string up in this bitch? Yeah, I guess we can. Okay. Can we get a motherfucking dog string? Alright, so how do we get this draw thing? Can we get a motherfucking dog string? This shouldn't be too bad. Dude, CATLAB is fucking sick. Okay, we could just do this. Oh yeah, we need to remove the self loops. We want to do this too. Node lab equals true. Wait, but that is not right. What was the code that I wrote to display the actual thing? Dude, this library is sick. Yo, am I fucking sick, bro? I think I might be fucking sick. Oh shit, I think I'm fucking sick. Oh my god. Oh my god. I think I'm fucking awesome. Okay, what do I do? Oh yeah, here's the binary. Oh, this is sick. I forgot about this. To graph is node node labels equals symbol label. Okay, cool. Cannot convert an object of type string 7. What if we tried... Okay, what if we tried this? Nice. Okay, so that's okay. Oh yeah, we want to filter the loops out of it. So wait, actually, I think I can write this myself. So we get a mask. So wait, so this, oh shit, we shouldn't have reread it. Oh boy. Can we skip the missing one? And then we skip the self loops. Wow, there's a lot of self loops. I mean, that makes sense. There's going to be one for everything. Okay, then we get the VIDs. Why are there so many skipped? I don't... Oh, no, yeah, I'm dumb. Dude, it's so fast. It's actually crazy fast. Wait, we don't want this. We want this. Hell yeah. OEIS reference graph viewer. I could use my old code, dude. What is this graph? Oh, it's a Rubik's Cube. What, bro? Consider a 3x3x3 Rubik's Cube, but only allow the moves T2, D2, F2. I don't even know what those moves are. Sequence gives number of positions that are exactly in moves from the start. Dude, it's a Fibonacci sequence. Wait, it's almost a Fibonacci sequence. We need to remove this stupid sequencing context thing. That's a really interesting one. All right, so there's this whole network of Rubik. I bet all of these are like Rubik's Cube related. Actually, that's probably not true. Oh, they are. It's all just Rubik's Cube stuff. That is awesome. That is so freaking cool, man. It's all just Rubik's Cubes. Wow. That is super fucking cool, man. All right, dude, this is so cool. All right, so wait, let's look at the other induced subgraph. I probably won't be able to plot it though because it's so big. Sequence and context destroys so much of this though. We need to filter that out. So then we need to write the parser for it. How long have we been streaming? 3 hours? It's not that long. But I need to write the script for this video I want to do on combinatorics. So, wait, what is this one? Number of possible permutations of a Rubik's Cube of size n by n by n. Wow, dude, the 2x2x2 Rubik's Cube is actually really big. I just want to Google this number. Awesome. Dude, it's crazy.
43 quintillion. That's the amount of states a Rubik's Cube can be in. In other words, there are more possible Rubik's Cube combinations than there are sand grains on Earth. Now, at first, this may sound like it's false information.
But what about the combinations? Is there a combinations thing? Well, I should be able to take... Would it be over n cubed factorial? Take this number and divide it by 8 factorial of 8. Let's see if I Google this number. Huh. So cool. Okay, wait, let's look at the big boy. Well, let's see. How close am I to being done? Hold on, does Snap still do stuff? Cool. So we need the other methodology too. Okay. So let me write a README. The first is just creating between all A codes found through a regex. The second is just looking at Y cross at the cross ref section. The third will be removing sequence in context and adjacent. What is it? Sequence? What is it? I don't even know what it is. Adjacent sequences. It's literally so beautiful. Oh, okay. Oh man, number of possible permutations of a Rubik's Cube of size n by n by n. You know what I don't understand? How they say the busy beaver thing grows faster than anything else. But it starts out like, I don't know. It goes to like 100. It's not that fast. This thing goes to like 3 million in a second. Look at this guy. I don't know any of this. Earliest discovered examples of a total computable function that is not primitive recursive. Okay, now I'm just like checking over and over again because I don't know what else to do. Wow, we're close. We're close. So let me go back to my list of interesting things to look at. We can just start to compute them. Let's go up to the top. Degree distribution, now that's interesting. Yeah, can we just do that? Out degree. Why did we call it simple? Dude, just call it DG. I'm not like a fucking. Okay. Interesting. Okay, wait. So hold on. One would hope that they don't shuffle anything around. So that means that base of one. Okay. Wow. Uh, is it 40 though? Oh yeah, it's totally 40. That is exactly what you would expect. That the prime numbers are the most referenced integer sequence out of all of them. Like by far? I don't know. Let's see. Is it by far? 43 is pretty important. Fibonacci numbers. That's so fucking cool, bro. That's so cool, man. Woo. Damn. Should we start to write a script for this? Because I want to make a TikTok about this. This, I made a list of the most important lists. This list is the list of all lists. You know, something silly like that. Wait, do I have a tally? Okay, whatever. 204. What's 204? Okay, wait. Wow, it actually goes down. They merged. So you found a link. That's cool. Okay, so what was I gonna do though? Yeah. Okay, so I wanted to do first dot first dot foo first 10 and then map x to is it id vid, or no, it's vid id x the Catalan numbers. A very large number of combinatorial interpretations are known. Binomial 2n n over n plus 1, 2n factorial over n. Why is that of importance? I've never stumbled on the Catalan numbers myself, so it's not like I So these are all of, oh shit, what the hell? No, what? Two 117, 108, 10. What was 10 again? The totient function. Count numbers less than or equal to n and prime to n. Oh, wow. What does that mean? It's a number theory thing, I guess. Number theory. 203, what is this? The sum of the divisors. Dude, I just love that. I just love this so much. What's up with 5? What's 5? Oops. Tau. The number of divisors, then you sum the divisors. What is sigma 2? So cool. So cool. So cool. I wonder what place my favorite is in. So that was 203. Wait, 5 was 5 the totient? No, yeah, 5 was tau, which is just the number of divisors. Oh, so actually it's interesting. The sum of the divisors has been, can we print show first foo 20? Let's see. Does that work? Doesn't really work. I wonder if we can do like a tally plot. There's probably a histogram. Can we just plot? I don't know. Wait, but we want the sequence number. So we want to do so we want to do map x to a first dot foo. We want all of them. Okay, so this is something. I don't know. I don't know what that is. Okay, but then what we want to do is I don't know, to last dot foo. Okay. Print first 20 PS 20. Okay, so we should get the name. Okay, then I gotta just look at the name. What was 79? Did I go to 79? I don't think so. The powers of 2. Pretty important. But it's like, what does that even mean, bro? Because what about the powers of 10? Why aren't the powers of 10 important? What if you just type in the powers of 10? 1, 10, 100, powers of 10. You gotta wonder, why is this not important? Who knows? Demotra, let me produce your album, bro. Demotra, what's up? What's hanging? What's slanging? What's slanging? Yeah. Where were we at? 41? What was 41? It's a huge reassurance. Oh, the partition numbers. Okay. So I should just do all Free me. Free me. Let's go. All right, so where were we? Where were we? We were at okay, we were at that. Yeah, that makes sense. Copying 2,000 numbers into there. I wonder if this works. No, sad. Whoa. How far are we into this thing? We're almost at 1,000,000 edges. That's kind of not that many. I mean, the number of edges in Wikipedia was like astonishingly big. But that makes sense though. Okay, wait, what was I doing? I was just looking at these. 2275. I love that we found this weird little niche of Rubik's Cube things. All these numbers are Brazilian. That's awesome. Hablas portugués? Semi-primes. Interesting. That's a cool sequence. How do you do the enumeration? Wow, that's really cool. I like this sequence. This is one of my new favorite sequences, actually. It's the semi-prime numbers. It's the products of two primes. What about the triprimes? Do I look up a triprimes? Triprime gaps. Fucking sick, dude. Triprimes mod 10? Odd triprimes? What about just the triprimes? Wait, this isn't right. Numbers that are a product of exactly 3 primes. Oh, here we go. They should call it triprimes. Right, it starts with 8. That's pretty sick. What about quad primes? Table read by row, n primes. But what about sums? What is the sequence for the sum of 2 primes called? Numbers that can be expressed as the unordered sum of 2 primes in exactly 2 ways. No. But what I'm trying to say is 4, 5, 6. Okay, so you got 2 plus 2, you got 2 plus 3, you got 3 plus 3, you got 2 plus 5, so you get 7. 3 plus 5, 8. 7, 8. Can you... What is the sequence for the number that... Wait, is this the Goldbach conjecture? I can't remember. There's some sort of thing where, like, can be represented as the sum of 2 primes. Oh yeah. Yeah. Of course there's not a sequence for this. Who is this guy? Man, that is awesome. Oh wait, he's from Königsberg? That's crazy. The city of topology. I love that. What does it say? Okay. That's so funny, dude. See, you can just like stumble on stuff that... Wait, that's wrong. That's the product of 2 prime. Wait. So wait, what if we just look up the natural numbers? I wonder if there's a thing that it's like conjectured sum of 2 primes. What if I just look up Goldbach? Number of... Gold box comment? That's so cool. Wow. Okay, so let's keep going. 41, 2275. Oh wait, did we just look at? Oh yeah, we just looked at that. The product of two primes. The number of distinct primes dividing n. Maybe we should do some tree traversals. See how far can you get. The primes was 40, right? So it should be. That makes sense. You can basically get everywhere. But actually, you know what I want to do? I want to do 1429. And I want to do wait, oh wait, no wait, I can't draw that. It's even bigger. Everything is so connected. So connected. Okay, wait, what was I gonna do? I forgot what I was looking at. I wanted to make some pretty pictures. I don't remember what I was doing. Wait. I don't remember. What was this one? What was this one though? I forgot. Oh yeah, the semi-primes. Dude, I like this one. Just weird stuff. What's 51? I feel like I already did all these. 2n plus 1. I feel like those are really lame. But they are prime. The Fermat primes. Oh, they're just doubly exponential primes. That's not that interesting. Wait, is that true? Dude, this guy Eric Weinstein. Dude, this guy's a freaking badass. Does he write all these? Like, I don't... So cool. I mean, damn. To keep a... I mean, Math World, you find everything on Math World. So imagine that it's just... I mean, he has so many comments. His name is all over. Okay, so we're at 51. The primordial numbers. The product of the first n primes. That's so funny, man. There's all these transformations that you can do. Wow. So 1, how do you even get 1? One doesn't really make any sense unless you say that 0 is prime. Is 0 prime? No way. I don't even want to distinguish that question. That would be crazy. Be crazy. That'd be fucking crazy. Okay, so 6, 2 times 3, and 2 times 3 times 5, 30. Then 2 times 3 times 5 times 7. Whoa, wait, these numbers are cool. 5, 10, 5, 10. And a 69. That's a nice one. What was that? 2110. Okay. Can you just do this? Prime omega? Cool. What does this do? Together with their exponents. That's why you do map at last. Fact 120, 2 to the 3 times, yeah, okay. What is slash at? That's map, right? So I don't understand. I don't really get that. It's kind of an interesting one. Where were we? Okay, 1, 2, 2, 2. Have we finished with this graph yet? The frequency of these self loops is going up like crazy. And some of these are just total bullshit. Alright, so where were we at? 720? 12. I think I've seen 12 probably. Who is referencing this, dude? Oh man, that's good. The Lucas numbers. It's a recurrence relation? This has got to be fib. Oh, weird. The Lucas numbers. I've never heard of that.
Okay, so Lucas numbers are named after a guy called Edward Lucas, although he was French, so Lucas, but I'm going to say
Lucas.
because I'm lazy. And if it wasn't for Lucas, we wouldn't really care about Fibonacci, because Fibonacci did some things. He wrote those numbers down, didn't generalize them, didn't analyze them. He did introduce some interesting, number systems to Europe, and he did some other cool bits and pieces. But these were more of a footnote to the story of his life. And then Lucas went, hey, these are really interesting. And he's the guy who promoted them. And he got with his own sequence, which is better than the Fibonacci numbers. And you think, well,
Nah,
Fibonacci
bro.
starts 1, 1.
Come on.
What was our next option? So Fibonacci starts 1, 1, and then it goes 2, and then 3, and then 5, and then 8, and then 13, and then onwards. Well, what if we start, instead of starting 1, 1, what if we start 1, 2? But we can't start 1, 2 because we're just starting here. All we've done is move along slightly, and so we're going to get the same numbers if we start 1, 2. Lucas numbers, you start 2, 1. So you just swap them around, and then you repeat exactly the same pattern. So 2 plus 1 then gives us 3, and then we get 4, and then you get 7, then you get 11 and 18, and these are the Lucas numbers. And to my mind, this sequence of numbers is far more interesting than the Fibonacci sequence of numbers. And these have a stronger link to the golden ratio. So if you take the golden ratio, phi, which is equals 1.618033988.
Wow, he's remembered a lot of digits. Good for him.
Okay, right, so we know for any of these sequences, they're going to approach that ratio. But what if we start with the ratio? What if we want to take the ratio and then get a sequence of numbers? So if you calculate phi squared equals 2.6 180, so on, which if you round to the nearest whole number is 3. So approximately, okay, so I'm going to do this column as rounding to the nearest whole number.
What?
Phi cubed equals 4.23606, so on.
No.
Which if you round to the nearest whole number is 4.
What
Phi
the
to the 4
fuck?
is 6.85410, so on.
And does it approximate it?
And if I carry on and take each of these and round
No,
to the nearest
dude.
whole number,
It's getting closer.
Sure enough, these are the Lucas numbers appearing up here.
That's
Carry on all the way
so
down. Every
interesting.
power of the golden ratio rounded to the nearest whole number gives you the Lucas numbers.
That's
why the
crazy.
fact that the Fibonacci numbers are linked to the golden ratio in a way that every other similar sequence is. If you start with the golden ratio and then take powers, is because what you're doing is you're multiplying each term by the by that ratio to get the next term.
Oh,
It's
that's
that wonderful
so
formula that bangs on.
fucking
But this is
cool,
these are the
dude.
numbers of
Okay, the
Fibonacci.
Lucas
You can
numbers
start
are
with that
sort
and then
of...
go to the sequence, and that's why I think the Lucas numbers are vastly superior. I mean, very careful.
That is crazy. The Lucas numbers. I've never heard of that before, ever. See, this is what I would say is like related to the human mind. Whereas like because we live in three-dimensional space, we care about cubes. I don't know. This is one of those ones where I'm like, is that actually cool, or is it sort of like if we were higher dimensional beings? What is this? Exactly, right. And they get like so much attention, but if you ask me, that's like not that cool. 8,000. Wait, we're only at, oh no, never mind, 500 still. Wait, are we sorting by in degree? We are, right? So a lot of people talk about these. But what is the point? I don't know. Wait, oh, is this a crystal? Oh, damn. Damn, that's really cool. See, okay, all right. So I know I was hating on the crystal, um, or on the sequences that are like related to humans, but that one I feel like is cool. Like even if it's just like simple polynomials or whatever, but like see they usually seem to have a closed form solution. But I mean, I'm surprised that that's so highly ranked. Where were we at? 8,000. But decimal expansion of... I like that these decimal expansion ones are actually in here. One, 2, 4, 7, 11, 18. That's so cool. These like simple programs. Like you just wouldn't expect it, man. But this is it, right? Why is geocaching? Why is this on a geocaching website? Who knows? Very silly. Are we done? We're not even done, dude. Probably getting bogged down with a whole bunch of nonsense. Yeah. Let's look at my RAM usage. Because if I'm just getting bogged down, then I should probably rewrite the code. It's not even using that much RAM. I feel like it's going really slowly. One plus the square root of 5 over 2. It seems so arbitrary. Dude, this one hurts my brain. This thing really hurts my brain. All right, I'm gonna do a few more, and then I think I'm gonna call it. Maybe we'll do a different stream where I need to work on this video. I'll keep this. I guess I got to keep this code running. There's so many more to do. Out of curiosity, I want to know what this one is. Dude, I want to find a sequence, man. But I want my sequence to be cool. You know? I don't know how long this thing is going to run for, man. Be excited to have it done. Okay, wait. Let's go back to the connected components thing. Was that it? Mining integer sequences. That's crazy, dude. Mining integer sequences. Who made this? Pretty cool. Okay, where were we at though? I don't even remember at this point. Wait, what was this sequence? It was about like the trace or something? Numbers with negative triangular trace. I don't even know what that means, dude. The world of numbers. It's just so cool. I don't even remember where we're at. 8,027. 1622, did we do that? Oh, yeah. One plus, what is x? Number of symmetric Farrer's graphs with n nodes. What are the Farrer's graphs? Is that 120? Or 700? Ramanujan theta functions? Who knows what that is? That's a neat one. Let me look at the Mathematica code. Oh, it's just digit count? Hey, 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 hey. Wait, are these also primes? No. 2 to the n plus 1 is prime. But 2 to the n minus 1 is not prime. I don't even know how do you prove that? With induction? I don't know. Alright, we're almost done. It was at 225. Alright, we're almost at the end of the top 30 sequences. Greatest prime dividing n. Oh, yeah. Right. Right. That makes sense. That's a good one. I like that one. I think my favorite one so far has been the Lucas numbers. That just seems so cool. Like, I need to think about that more because that is just such a neat thing. Wow, this one's relatively new, up to 10,000. Oh, that's stupid. It's just a mask. It's just a mask, bro. Don't we all just wear masks? Skeet. All right, that's it. Exploring the world of mathematics.